Hello and welcome to Chapter 10, Section 6. Today we're talking about theoretical probability. Yesterday was experimental probability. That is, if we try it a bunch of times, we see that it works this way. So we think next time it's going to happen similarly. This is what we can use when the outcomes have the same chance. It's not just what's grandpa gonna say, but you know, when we flip a coin or choose a card out of a deck or something like that. Something that is equally likely to happen. For example, if you have a spinner with 4 colors and all 4 of those colors have an equal area, then you can come up with a theoretical probability. You know that there is a 1 in 4 chance, there is a probability of 25% that you're going to spin any one of these 4 colors. Whereas with this spinner, you can't use theoretical probability on it. You have to break it down mathematically. So we're talking about these. Theoretical probability is the number of ways that an event can occur over the total number of equally likely outcomes. So for this spinner, if I said, what is the theoretical probability that I will spin a red? I can spin a red once, but there are a total of 4 equally likely outcomes. So it's a 1 in 4. So it's a 25% chance. Experimental is based on what happened before. Theoretical is based on the chance. And we write these in percentages. So some sample questions would include, what is the theoretical probability of rolling a 3? A number cube has 6 numbers on it. It has 6 numbers and there is 1 3 on it. So this is something we put into our calculator to write down the percentage, which is 16.7%. What is the probability of rolling a number greater than 3? Well, that would be 4, 5, and 6. So there are 3 possibilities out of 6 total possibilities. So this would be a 50% chance. Choosing a face card in a deck. There are 3 face cards, Jack, Queen, and King. 3 face cards in each suit. There are 4 suits, so there are 12 face cards in a deck. There are 52 total cards. So we're going to do this math, and we get 23%. And finally, spinning a primary color. So if we're looking at this spinner again, we have red, blue, purple, and green. Purple and green are composite colors. Red and blue are the primary colors. So we have 2 winning chances out of 4 total chances. And again, we've got a 50% probability of that. So let's talk a little bit of math now. When flipping a coin 10 times, the probability that you will flip a heads plus the probability that you will flip a tail equals 100%, and that equals 1. This is how you write this, the short way. The probability of heads is a 50% because heads is 1 outcome out of a total of 2 outcomes. The probability of a tail is also 50%. It's 1 in 2. And when you add the probability of heads and the probability of tails, you get 1. When you add up the probability of all the possible outcomes, it should equal 1, or you're probably doing something wrong. Heads and tails are called complementary events, and complement with an E. Not like compliment with an I that says, oh, you have pretty eyes. This is the probability of an event, and the probability of the complement of the event, which means the event not happening, is going to equal 1. So then they're going to ask you a lot of questions that sound kind of stupid. If you know that the probability that it's going to snow is 20%, what is the probability of it not snowing? And you say 100% minus 20% equals 80%. If there is a jar of marbles and the probability of pulling a green marble is 0.2, and you can make that into a percent, and the probability of blue is 0.3, and the probability of purple is 0.1, what is the probability of white? If I told you that these were the only possible colors in the jar of marbles. And so you would say 0.2 plus 0.3 is 0.5, plus 0.1 is 0.6, which leaves 0.4. So there is a 40% probability that you will pull a white marble. I am going to give you a quick lesson on cards. Some people are familiar with a deck of cards. Some people have literally never picked up and played with a deck of cards since they played Go Fish in the first grade. So I'm talking about a standard deck of cards, not an Uno or any fancy anything. A standard deck has 52 cards total. It's broken down into 4 suits: hearts, diamonds, spades, and clubs. A spade is a heart upside down with a line through it. It's supposed to look like a pointy shovel. And a club is a 3-leaf clover. There are 13 cards in each suit, and 13 times 4 is 52 total. So there are equal numbers of each number. There is ace, 2, they don't have a number 1, I don't know why. Ace, 2, 3, 4, all the way through 10, and then jack, queen, king in each suit. So you've got 13 of these with a heart on them, and 13 of these with a diamond, and so on. Each suit has 3 face cards. 3 face cards times 4 suits is 12 face cards total. 26 of the 52 cards are red and the other 26 are black. So in probability, they like using decks of cards because sometimes it comes out equally, red versus black, or there are 4 5s in and 4 6s and 4 9s, and sometimes it comes out unequally, which is the pulling the face cards out of a deck, that kind of thing. Okay, we've been talking about probability. Now we're going to start to talk about odds. The odds of something happening is also a ratio, a fraction, of the number of ways an event can happen over the number of ways an event fails to happen. This is heads over tails, not heads over total. Heads over total is probability, heads over tails is odds. So when you say the odds of something happening, this is a 1-to-1, where this is a 1 in 2. So when you're reading the paper or looking at sports games and probabilities and statistics and things like that, it's important to know the difference between these two. So now we're going to play with these a little. What are the odds of rolling an even number? Well, an even number on a dice is 2 or 4 or 6, and then, so there's 3 of them, and then not rolling an even number would be a 1, 3, or a 5. So that is a 3 to 3. The odds are 3 to 3, and they can be written like this or they can be written like this. Both of these are the same. So if you see this in the answers and you wrote this, it's the same thing, or vice versa. What are the odds of choosing a red card in a deck? Well, there's 26 red cards and there's 26 black cards. So the odds are 1-to-1 that you'll choose a red card. The odds against choosing a green marble are 5 to 3. 5 against, 3 for a green marble, which means there are 3 green marbles. What is the probability of choosing green? Well, choosing green, we know there are 3 green marbles, and then we need the total of marbles, which is the green marbles plus the not green marbles, which means 8. So there's a probability of 3/8, and you would write this in a percentage or a fraction. The odds in favor of winning a prize is 1 to 24. What is the probability of winning? Well, we know that there's there's 1 shot at winning and there's 24 shots at losing, so altogether there are 25 shots. There are 25 chances. So 1 in 25 is your probability ratio, and you would then make that a percent. And that is theoretical probability. So your homework today starts on page 748. You're going to do 14 through 30 even. If you have any questions, please let me know. I'll see you tomorrow.